Okay, so we wish to show that the sine square of theta plus cosine theta equals 1. This is one of the very first trig identities that we learn in trigonometry. This is intended for an advanced geometry class. So here we're going to show that this is true by starting with the equation of a circle at the center at the origin. So we're going to write x squared plus y squared is equal to r squared. Here we can see that if I divide everything by r squared, like so, then we have x squared over r squared plus y squared over r squared equals r squared over r squared, which just happens to be a 1. So if you notice, I have cosine of theta equals x over r. So if I were to square this on both sides of the equal sign, I would get cosine squared theta equals to x squared over r squared. Similarly, if I do the same thing to the sine of theta here, so we're going to have the sine square of theta equals y squared. Sine, let me check that a little bit here real quick. That should be the sine squared theta equals y squared over r squared. And we can substitute that into our equation over here. So cosine squared theta will replace this expression right here. So we would get cosine squared theta, and this expression here would replace this expression here, and that would give us sine squared theta, and this is equal to 1. So basically this is very straightforward, nothing complicated about it. All you have to do is do a simple substitution, and you can show that both sides are equal. Anyway, so let's start with something a little bit more complicated. Nothing too complicated, but let's go with secant of theta. Secant theta minus the cosine of theta. And that is supposed to be equal to the sine of theta multiplied by the tangent of theta. Well, now this doesn't seem like it would be equal, so the process here would be to start with a more complicated side. In this case, secant theta and cosine minus the cosine theta looks a little more complicated than this side. So what we do is rewrite secant theta as the reciprocal of the cosine. So we're going to have 1 over cosine minus the cosine. And I'm going to try and write this as one denominator. So this becomes, let me move this in a little bit down for you so you can see it better. About that. And if I multiply the numerator and the denominator by the cosine of theta over cosine of theta, we can see that the denominator will become 1 minus cosine squared theta all over cosine theta, like this. And that's supposed to be equal to sine theta tangent theta. Now, this equation here, if you remember, we had sine squared theta plus cosine squared theta equals 1 from the previous identity. And if I subtract cosine squared theta from both sides of the equal sign here, this will give us that the sine squared theta is really 1 minus the cosine squared theta. And then we can replace this with this. in this expression. So then this becomes sine squared theta over cosine theta. And if we break this apart, leave it as a sine of theta, sine theta over cosine theta, we can see that this becomes sine theta times the tangent of theta, because tangent is sine over cosine, and this is identical to sine theta multiplied by the tangent of theta. Tangent of theta. Okay, so as again, identities are can be a little complicated. However, if you take your time and start with the most difficult side first, and then move on from there, they're not so bad. Let's try another example. This one's a little more complicated, not by much. Suppose we have the secant theta is supposed to be equal to the sine theta. Multiply that by tangent theta plus cotangent of theta. Again, you always do the more complicated side. So in this case, we're going to start with the right side and make it look like the left side. Here, however, we're going to do the inside of the parentheses first, so we leave the sine of theta alone. Now this becomes sine theta over cosine theta, and then the cotangent would be the reciprocal of the tangent, so this would be cosine of theta over the sine of theta. So far so good. And of course we got to have a common denominator. You can see that the denominator will be the product of the denominators in this case. So we would have to multiply sine theta by sine theta. So we would get sine squared theta, and multiply this one by cosine theta. We would get cosine squared theta. Everything over sine theta, cosine theta, like so. And if you recall from a few steps ago, we showed that sine squared theta plus cosine squared theta is 1. So remember, we have a sine theta out here. So this becomes sine theta times 1 over sine theta cosine theta. And you can see that the sine theta will divide the sine of theta over here, and we are left with 1 over cosine theta. But we all know that 1 over the cosine theta is really identical to the secant of theta. And we showed that the secant of theta was equal to all of this expression here. So as we said before, always start from the more complicated side, and then things will work out. All you got to do is go slow.